In this video, we're going to talk about properties of exponents. So first, we need to identify the parts. So if you have x raised to some number, then the x is the base. The number that it's being raised to is the exponent, and then the entire thing is called a power. So when we're talking about the base, make sure you know which part that is, which part is the exponent, and then when I refer to the power, that's technically the entire thing. So we have four properties that we're going to talk about. The first one is when you multiply two powers with the same base. So x is the base. This entire thing, x to the m is a power. X to the n is a power. So I am multiplying two powers with the same base. To do that, you keep the base the same, and then you add the exponents. So x to the m times x to the n is the same thing as x to the m plus n. That means if you have x to the third times x squared, that is the same as x to the fifth. You would add the exponents together. Similarly, when you are dividing two powers with the same base, instead of adding the exponents, we're going to subtract the exponents. So if I had x to the sixth divided by x to the fourth, 6 divided by 4 would be 2, so that would be the same as x squared. When you have a power raised to a power, so this right here, x to the m is a power, and then the parentheses raised to the nth is a power, so I have a power raised to a power, you multiply the exponents. So if I had x to the fourth, and that entire quantity was squared, 4 times 2 would be 8, so this would be the same thing as x to the 8th. And then again, instead of raising it to a power, if you go to a root, so if I have the nth root of x to the m, here I'm going to divide. I want you to think about what we did in the last lesson where we rewrote them. N would be in the denominator, so it would be m over n, and then you would just divide your exponents. So if this were, I don't know, the square root of x to the fourth, 4 divided by 2 would be 2, so this would be the same. If I had the square root of x to the fourth, that would be the same thing as x squared. So now we're going to do some examples. So here I have x to the ninth, and that entire quantity is raised to the 1/3 power. So a power raised to a power, we multiply the exponents. So if I were going to multiply 9 times 1/3, 9 is the same as 9 over 1. When we multiply fractions, we multiply straight across the top and straight across the bottom. And 9 divided by 3 is 3. So this right here would be the same thing as x to the third. So as we get more and more complicated with our problems, you need to just think about your order of operations. What do you do first? So anytime there's a set of parentheses, you probably want to do what's in parentheses first. So the x on top I am leaving alone. Inside the parentheses I have 2 times 2, which is 4. I have x squared times x. That's the same as x to the first. So if I'm multiplying two powers with the same base, I add the exponents. So that would be x to the third. And then the entire thing is to the third power. So now, in the denominator, I have to do 4 to the third as well as x to the third to the third. So 4 to the third is 64. And then I have x to the third, so a power raised to a power, I multiply the exponents, that would be x to the ninth. So now I have 1x on top and 9x's in the denominator. I can get rid of this entire x on the top if I get rid of one of these, which would leave me with 8. Now if I cancel out, there was still 1x there, so this would be the same thing as 1 over 64x to the 8th. Some of you, when you cancel everything out of the top, you say that this is 64x to the 8th, and that's your answer. Just keep in mind, if that was in the bottom of the fraction, then it would need to stay in the bottom of a fraction. these two are not the same thing. So make sure you keep track of where your answer should be. Should it be in the numerator or the denominator? This is x to the 0 power. Anything to the 0 power is equal to 1. That's going to be helpful when you look at problems like this. No matter how complicated it is in the parentheses, as long as you're paying attention and you recognize that this entire quantity is to the 0 power, then that will save you a lot of time because this is just 1. I don't need to simplify anything going on in here. I just know that because it's to the 0 power, it's 1. Next, we need to talk about negative exponents and how we treat those. All of our answers need to make sure that our final answer is a positive exponent. So if we end up with a negative, we need to know how to take care of that. So first, it's important to recognize that this negative 2 is only to the x, not to the 2. If I want to get rid of a negative exponent, all I need to do is move that to the other side of my fraction. So if it were a negative exponent in the top, then I would move it to the bottom. If it's in the bottom, then I would move it to the top. So now I already had an x on the top. I've taken this x to the negative second, and this becomes x to the positive second. Basically, it's cashing in its negative when it goes to the other side over 2. So now I'm multiplying two powers with the same base. This is the same as x to the first, so I add the exponents. So this would be x to the third over 2. You're also going to see negative exponents like this on the outside. So first, remember order of operations. We want to clean up what's inside parentheses first. We don't want to mess with everything else until we kind of simplify it as much as we can. So this negative exponent I'm going to take care of when I move that to the bottom of my fraction. So on the top of my fraction, I still have y to the fourth. On the bottom, I have 2x squared times, now I have a positive x to the third. And that entire thing is to the negative third. I can still take care of this. This is two powers with the same base being multiplied, so I add their exponents. So this would be the same thing as y to the fourth over 2x to the fifth, and then the entire fraction is to the negative third. So if your entire fraction is to a negative exponent, that means that you need to switch the top and the bottom of your fraction. So this would be the same thing as y to the fourth, 2x to the fifth over y to the fourth, and now instead of that being to the negative third, it's to the positive third. So 2 to the third would be 8. X to the fifth to the third is a power raised to a power, so I need to multiply the exponents, so that would be x to the 15th. Same thing here, I have a power raised to a power, so this would be y to the 12th. So this entire thing simplifies to 8x to the 15th over y to the 12th. Now we're going to talk about what happens when our exponents are fractions. We want to make sure that we don't write any of our final answers as fractional exponents or rational exponents. We learned in the last section how to rewrite it from exponential form to radical form. So if you end up with your final answer having a fractional exponent, then we want to rewrite that so that it's in radical form. So first, I'm going to clean up what's in the parentheses. So I have x squared over x to the third to the 1/2. So now I have a power raised to a power, so I multiply the exponents. So on top I still have x squared. On the bottom, 3 times 1/2. This is the same as 3 over 1, so that would just be 3 over 2. So this would be x to the 3/2. You need to make sure that you don't have x, or any variable, written in more than one location, or else you can keep simplifying. So now I have a power divided by a power, and they have the same base. So here's where I would subtract my exponents. So I want to do 2 minus 3/2. I have to have a common denominator. So this 2 is really the same thing as 4 over 2. So if I do 4 over 2 minus 3 over 2, then I'm going to get 1 over 2. So this would be x to the 1/2. But I don't want a fractional exponent, I need to rewrite that. We learned in our last video that x to the 1/2 is the same thing as the square root of x. So my final answer for this would be the square root of x. So hopefully that's enough to allow you to do the homework on properties of exponents that's over on the right.